Hello students and welcome to my channel Maths Hub. So today in this video, I will be telling you about how to solve a Laplace equation. So let us try to understand what is a Laplace equation. So we have already studied heat equation. So heat equation in one variable is given by del U by del T is equal to C square del square U by del X square, right? So if I extend this heat equation to two dimensions, that is heat equation in two dimensions, then what happens is that we have another parameter associated to it, that is y variable, right? So heat equation in two dimension becomes del U by del T is equal to C square. One component is x, del square U by del x square, and the second component becomes del square U by del y square. Now this heat equation in two dimensions, if we consider the steady state conditions, so under the steady state conditions, what happens? Del U by del T becomes 0. So if del U by del T becomes 0, if I equate it back into this equation, this term becomes 0. So the equation reduces to del square U by del x square plus del square U by del y square is equal to 0. So this equation is termed as the Laplace equation. That means you can also say that a Laplace equation is a two-dimensional heat equation under steady state conditions, right? Now let us try to solve a Laplace equation with given conditions. So the question says, find the steady state temperature distribution in a thin rectangular metal plate 0 less than x less than a, 0 less than y less than b, with its two faces insulated, with the following boundary conditions prescribed on the four edges: u at 0, y, u at x, 0, u at x, b, they are all 0, and u a, y is equal to 100, where y lies between 0 and b, right? So how to solve this problem? We know that we solve all the applications of PD by the method of separation of variables, right? So we know that under the steady state temperature distribution, the Laplace equation turns out to be del square U by del x square plus del square U by del y square is equal to 0, right? Now from here, according to the method of separation of variables, u is equal to a function of x into y, where capital X is a function of small x and capital Y is a function of small y, right? So according to the given equation, we have to calculate del square u by del x square, which becomes x double dash y, and the second condition that is required is del square u by del y square, which becomes xy double dash, right? Now let us substitute these values in the Laplace equation. So the Laplace equation becomes x double dash y plus x y double dash is equal to 0. So you can separate the variables on both sides. So on separating the variables, we get x double dash by x is equal to minus y double dash by y, right? Now, while you are solving a Laplace equation, what you have to keep in mind? Now, how to decide what will be the signs? Now, what is tricky is where to keep the sign of negative, whether it should be with x or it should be with y. So, how to decide about it? What we will see, we will check the initial conditions, right? So, the first initial condition says u0, y is equal to 0. So here u is a function of x and y. So the first condition is on x and the second condition is on y. So when we are putting u is equal to x into y, that means what is becoming 0? Small variable x is becoming 0. So that implies x at 0 is equal to 0. So this is what is implied from the first condition. Now the second condition is ux comma 0 is equal to 0. That means now the condition is on variable y. That means y at 0 is equal to 0. Now the third condition says ux comma b is equal to 0. So this implies y at the point b is equal to 0. So from these three conditions, whose conditions are more? Is it for x or is it for y? They are definitely for the variable y, right? So the conditions for whichever variable is more, that will be kept positive and the other variable will have the negative sign, right? So since x had conditions less, so we will keep the negative sign on the variable x, right? And we will start with the conditions on y first. Now, as in the method of separation of variables, we put it equal to constant k. Now, what are the possible values of these k? K can be 0, k can be positive, or k can be negative, right? So, we will first take the case when k is 0. Case number 1, when k is equal to 0. So, let us take y double dash by y is equal to 0. So from here, the equation that is framed is y double dash is equal to 0. So if I convert it into an auxiliary equation, it is d square y is equal to 0. So that implies d square is equal to 0. We convert it into an algebraic expression. So we will get m square is equal to 0. So which implies m is equal to 0, comma 0. The two roots are 0. So from here, y comes out to be c1 e raised to power 0y plus C2 e raised to power again 0y, and with the second variable, since the roots are same, we will multiply a y along with it, right? So we can say that y comes out to be C1 plus y times C2, right? Now, let us try to calculate the values of these constants C1 and C2. How to calculate C1 and C2 now? The first initial condition says y at 0 is equal to 0. We will take the conditions from here. Now if y at 0 is equal to 0, so let's place capital Y 0 and small y 0. So what do we get? We get 0 is equal to C1. This term will become 0. So if C1 is 0, that means y reduces to y times C2 now. Now let us take the second initial condition. That means y at b is equal to 0. So let's put y is equal to 0 and small y is b times C2. So this implies b cannot become 0, right? So that means C2 is equal to 0. So if both C1 and C2 are 0, that means y is equal to 0. And if y happens to be 0, that means u is also 0. So if u becomes 0, maybe whatever is x, so that is always a trivial solution, right? But we are not interested in trivial solution. We are interested in a non-trivial solution. So we reject this case, k equal to 0, we reject this, and we move on to the next case, that is k is positive, right? Now when k is positive, we again pick up this equation, y double dash upon y is equal to positive means now we take k as p square, right? So whatever is p square is always going to be positive. So from here, when we try to frame the equation, we get y double dash minus p square y is equal to 0, right? So from here, the auxiliary equation is d square minus p square into y is equal to 0. So the algebraic expression becomes m square minus p square is equal to 0. So this implies m is equal to plus minus p. If m is equal to plus minus v, that means what is y? Y is c1 e raised to power py plus c2 e raised to power minus py, right? The roots are real, so we get real and distinct, right? So now let us again put the conditions on y. So the first condition on y was y at 0 is equal to 0. So from here, what do we get? 0 is equal to y is 0. So we will get c1 e raised to power 0 will become 1. c1 plus c2. So this implies c2 is equal to minus c1, right? Now let us imply the second condition, y at b is equal to 0. If y at b is equal to 0, okay. So if C2 is equal to minus C1, I can change my y. Y will become C1 e raised to power py. In place of C2, I can replace it with C1 minus C1 e raised to power minus py. Now y at b is equal to 0. What will this imply? Y is 0 and we will get C1 is common. So I will get e raised to power pb minus e raised to power minus pb, right? So now this exponential term is never 0. So if this exponential term is never 0, that means C1 happens to be 0, right? And if C1 happens to be 0, in the last step C2 was minus C1. So that implies C2 is also 0. So again, what value for y we are getting? We are getting y is again 0. And if y happens to be 0, that means u is 0. And again, it is leading to a trivial solution, which is not possible, right? So again, we reject this case. And now we move on to the third case, that is when k is a negative number, right? So when k is a negative number, y double dash by y, we put it equal to minus p square, right? So now y minus p square, because irrespective of p, whether it is positive or negative, p square is always going to be positive. So minus p square will make it a negative number. Now let us cross multiply and frame the equation. So we will get y double dash plus p square y is equal to 0. So that will imply that b square plus p square into y is equal to 0. So the auxiliary equation will be d square plus p square is 0, which will make the algebraic equation to be m square plus p square is equal to 0. So from here, what does it yield? It tells us that the value of m is equal to plus minus iota p, isn't it? So the roots are imaginary. If the roots are imaginary, then what is the value of y? Y comes out to be C1 cos py plus C2 sin py, right? So now again, our job is to calculate the values of these constants. So we first put the first condition that y at 0 is equal to 0. If y at 0 is equal to 0, that means 0 is equal to C1. Put y0, cos of 0 is 1. So we will get C1 plus C2. Sine of 0 is becoming 0. So automatically the term C2 becomes 0. So from here, we get C1 is equal to 0. That means y is now left as C2 sin py, right? Now let us apply the second condition. The second condition says y at b is equal to 0. So what does this imply? 0 is equal to C2 sin P by PB, right? Now, if C2 happens to be 0, what will happen? Again, y will become 0 and that will lead to a trivial solution. So only this case is left. So what we say that we have another option that C2 cannot be 0. If C2 is not 0, but the product of these two terms is 0, so what does it imply? That sine PB has to be 0, right? And when sine terms are 0, sine terms are only 0 when it is equal to sine n pi, right? So from here, when we compare the angles, we get PB is equal to n pi, which implies we get the value of P as n pi by B. So from here, we get y as C2 sine. We can put the value of P here. So it is n pi by B y. So this is the value of y that we obtained in the method of separation of variables. Now for this case, same case, case number 3, we will calculate the value of x also, right? Because in the other two cases, the values of y are trivial, so we are rejecting them. So let us move on to the next step where we are calculating the value of x, right? So I'll just write down what is y coming out to be. So y is coming out to be C2 sine n pi by b, right? Okay. Now, if you remember the equation for x, the equation for x was minus x double dash by x, and we are taking the third case when k is minus p square, right? So both the negative signs will get cancelled, and when you frame the equation, you will get x double dash minus p square x is equal to 0. So from here, the auxiliary equation is d square minus p square into x is equal to 0. That implies the auxiliary equation is d square minus p square is equal to 0, or the algebraic expression is m square minus p square is equal to 0. So from here, the roots of this equation are m is equal to plus minus p. So what is x? X turns out to be C1, C2 I've already used. So I will use C3 e raised to power px plus C4 e raised to power minus px. Right? Okay. So now one initial condition that is left is x at 0 is equal to 0. So let me put 0. So we'll put x also 0. So we will get C3 e raised to power 0 is 1. So we will get C3 plus C4. So I can replace C4 as minus of C3. So x turns out to be C3 e raised to power px minus C3 e raised to power minus px. So I can write this expression as C3. I can take out e to the power px minus e to the power minus px. Right? Now, we have done the definition of sine hyperbolic x. So what is sine hyperbolic x? It is e to the power x minus e to the power minus x divided by 2. Right? So you can write this expression now as 2 times C3 sine hyperbolic px, right? If you replace x with px, you will get sine hyperbolic px here. So this is your x, and we have got the value of y. So you can frame your u. So u turns out to be x into y. So we will get 2c3 sine hyperbolic px multiplied by y is c2 sine n pi by b y, right? Now I can do one more step. I can put the value of p here. So that will become 2c3 c4, c2, and then I can write here sine hyperbolic n pi by bx multiplied by sine n pi by by, right? Now, what is the last condition left? You are given the last condition as u a comma y is equal to 100, where y lies between 0 and b. So now this is the value of u for constant C3 and C2. So if you can see here the value n is coming. So this u is valid for all values of n. So if it is valid for all values of n, I can replace this constant by summation bn, where n goes from 1 to infinity. Since this value is running for all values of n, so I can replace this with bn constant, and I can sum up all the values of n, right? So I get this expression. Now, let us apply the last condition, that is u a comma y is equal to 100. So when I apply this condition, I get 100 here, and I get summation n going from 1 to infinity bn. We have to put x equal to a. So we have sine hyperbolic n pi by ba multiplied by sine n pi by by. Now, does this make you recall for anything that we have done before? You can see that this is a sine series, right? It's a Fourier sine series, and you can see that this is the constant. This term is also a constant and Bn is also a constant. So you can consider this whole term as a constant, and this is the value of the function, right? So according to Fourier sine series, how can you write your expression? How will you write it? You can say that the coefficient Bn into sine hyperbolic n pi by Ba is equal to, so it's a sine series. So we can say 2 by L. L is B, the length of the interval. On this limit we are integrating it. 0 to B, the value of the function is 100 multiplied by sine n pi by B y dy. Right? So from here you can take out 200 common. 200 by b. Now what is integration of sine? It is minus cos n pi by by divided by n pi by b, and you can put the limits from 0 to b. So this will turn out to be 200 by b with the minus sign into b by n pi, and when I put b, I'll get the limit as cos n pi. B and b cancels. Cos n pi is minus 1 raised to power n minus, when I put 0, I'll get cos 0 as 1. So b cancels from here. So what is the value of bn? So bn comes out to be minus 200 by n pi minus 1 raised to power n minus 1 divided by sine hyperbolic n pi by b into a, right? So now this is the value of bn, and finally what is u? We will put the value of b in this. So u comes out to be summation n going from 1 to infinity. We will replace bn with minus 200 by n pi minus 1 raised to power n minus 1 divided by sine hyperbolic n pi by ba multiplied by sine hyperbolic n pi by bx multiplied by sine n pi by by. So this comes out to be the value of u under the steady state temperature conditions, right? So the only trick is that how to place negative sign, whether it is to be kept on x, whether it is to be kept on y, that is determined by the initial conditions. Whichever variable has more conditions, that variable will be kept positive and the other variable will become negative, right? So I hope you understood the question. So please try the next question. So do try this question and do let me know whether you could solve it in the comment section, right? So with this, I finish this video, and do check my next video where I have taken the case on the variable x, right? Where more conditions are on the variable x. So thank you so much. Believe in yourself and you will able to do it. If you like the video, do hit the like button and do subscribe my channel to get the latest videos. Thank you so much.